So good evening, everyone. My name is Ritesh Jha, and I'm a second year PhD student, and I'm currently working with Professor Ravi and Professor Ashwin sir. So my presentation will discuss about the active break spin and the intra-seasonal variation. And another approach to study the intra-seasonal variation is the intra-seasonal oscillation modes. And we'll try to find the relationship between ISO and ISM, Indian summer monsoon rainfall. Then second section of my presentation will have the predictability, whether the prediction at intra-seasonal scale is good or bad, or why is bad. Then third, I'll talk about the challenge which was launched by the World Meteorological Organization. And in that, they have to predict the precipitation at intra-seasonal scale using AI/ML method. So first is ISM. ISM usually happens between every year between June to September. And during this month, Western India and Central India will receive around 90% of their annual rainfall. And by intra-seasonal variation, I refers to the variability within a season that lasts between weeks to months. In Indian context, ISB is mainly categorized by the active spell and the break spell. By active spell is mainly have the spell which have heavy rainfall, and by break periods we mean the little to no rainfall. The standard definition of active and break spell. So we take the rainfall data, we normalize it. If the normalized rainfall anomaly is less than -1 for the continuously 3 days or more, then we consider it as a break spell. Now, if the normalized anomaly is more than +1 consecutively for 3 days, we consider as an active spell. Now, if we focus over this monsoon core region, the inter-annual variability of ISMR is highly correlated with the variation over this region, which is about 91%. So if we are able to study the variation over this core region, we'll be able to find the inter-annual variability of whole India ISMR. Active break spell. So this is the from Rajivan paper in 2010. So in this paper, they discussed about the active break spell, and we will see that around 80% of the active spell, the duration of it that is 3 to 4 days only, and very few has the duration more than 3 to 4 days of active spell, and usually break spell is usually longer than the active spells. And the reason for the short duration of active spell, which was mentioned in this paper, is the synoptic system which comes from the Bay of Bengal usually have the lifespan of 3 to 4 days. And if another synoptic system from the Bay of Bengal overlaps the previous one, then only the time period of active spell increases to 1 week and beyond. Now, break spell usually has a longer time period because in order to convert the stable environment of the atmosphere over the monsoon, either the system from the north, from the system from the Indian Ocean moves northward to the monsoon core region, or the synoptic system from the Bay of Bengal established over the central India or the monsoon core region, then only we can see the conversion from the break spell to active spell. And there is also a tendency of quicker transition of active to break rather than break to active phase. Now, this is the composite of active periods between the year of 1951 to 2004, and this lag 0 is considered to be the time period when the positive anomaly established over the monsoon core region. And if we go back 12 days back, we see that the large part of the monsoon core region is negatively anomaly established over the large part over the monsoon core region, and the positive anomaly, the intensity is very low. As the time passes, the intensity and the zonal band starts moving northward, and by the time at lag 0, intensity intensified and it established over the monsoon core region. Now, as the time passes, this positive anomaly starts shrinks and again moves to the northward propagation. Again moves to the north. Now, two things can be seen in this paper is at lag 0, Himalayan foothills, north-east India and the southern East India have negatively correlated with the monsoon core region. So there is a northward propagation and these three regions have the negative correlation with the monsoon core region. And if we see the break composite, also it will be the same as this only, but there is the negative anomaly at lag 0 for the break composites.
The minus 12 and plus 12 are not symmetric. Any comment on that by the paper? Look at minus 12 and plus 12.
So
I would expect that the way it has been defined and the middle of the active period, right? I would have thought it would have been symmetric. No.
So basically the time period of northward propagation is not, 24 or 30 days. Okay. So it changes. So yeah. Now this plot is between the SMR and the number of break days. And few things from this paper is the correlation of number of break days and the ISMR is significantly high, which is around minus 0.61, but it's still scattered. If we see, for example, 1991 and 1974, there were not a break events in 1991. Still, will be around 8% of rainfall deficient. In 1974, there were only 3, but still it was drought year. But if the drought years in July and August exceeds 15 to 18 days, then for sure it will be a drought year only. For example, if we see 1972 and 2002, monsoon starts fine in 2002, but the onset over the Kerala in 1972 was late. But still, both were drought years, as number of dry spells in July is very high. So prediction of active break spell at intra-seasonal level is very important even for the seasonal mean also. If you're able to predict active break spell, we can predict the seasonal mean also. Now, till now we have discussed one approach to study intra-seasonal, which is focus on the special events active break spell. Now the another approach is focus on superposition of waves and spatial patterns, which is also considered to be as ISO modes. So inter-seasonal variation has the oscillatory modes, which have the time period between basically 2 time periods. First is which we call as a high frequency intra-seasonal oscillation mode, which lasts around 10 to 20 days. And the second one is low frequency intra-seasonal oscillation mode, which lasts around 20 to 60 days. The basic structure of northward propagation, the LFI is northward propagation from the equatorial Indian Ocean. And that of HFISO is a northwestward propagation from the Bay of Bengal. And the first intra-seasonal pattern, this intra-seasonal pattern was first discovered by Sikka and Gatkin in 1980 and Yasunari in 1979 independently. And this northward propagation can also be seen in raw data. This is the Muller of 2005, which was averaged over 75 and 80, and we can see the northward propagation from the raw data also. Now, this is the basic structure of the LFISO, and this is the composite of all the LFISOs between 1998 and 2004. And we can clearly see the 2 favorable region for convection, that is equatorial region, and another was monsoon core region. And there is the seesaw over between the equatorial Indian Ocean and the monsoon core region. So whenever there is a convection system over one area, the other will have the negative anomaly. Now, if we focus on phase 6, 7, and 8, there is a eastward propagation in Indian Ocean. And when it reaches the Philippines, it breaks down into 2 parts. One goes to the southwest and one goes to the northwest. This northwest has the 2 things. First, the system when reaches the Bay of Bengal gets intensified, and which may lead to the low pressure system also. And here we can clearly see the northward propagation of this, northward propagation of this system in subsequent phases. Now, HFISO. So this is the basic structure, and like I talked about the eastward propagation of Indian Ocean, here also we can see the eastward propagation of Indian Ocean, and it reaches the Philippines island, breaks down into two parts, and the one part which goes to the Indian landmass start intensified over the Bay of Bengal. If you focus on the star, this star represents the maximum positive anomaly over Bay of Bengal. And if you focus on the star, this star intensified in phase 6, phase 5, and phase 7, and this star moves a little bit westward. So there would be two systems, one in Arabian Sea, one in Bay of Bengal, and the Bay of Bengal shows the north-westward propagation, and anomaly over the Arabian Sea moves only northward. If you see the Arabian Sea, it moves only northward direction. So this is the basic structure of LF and HF. Now we will see whether this LF and HFISO actually modulates the active break spell or the ISMR or not. So Karmaka has found that the ISM rainfall anomaly and has a very high correlation with LFISO and HFISO, and the values are -0.64 and 0.74. He also found that LF and HFISO can both have impact of rainfall over central India. And what they have done is they found the +1 events, or the events which have active, say normalized, if normalized anomaly is more than +1. So, and if less than +1, they considered as a -1 event, and for +1, they have considered as a +1 events. So there were 310 +1 events and 281 -1 events between the years of 1998 and 2004. And they found that out of this active and break days, 60% occurs of +1 events in 2 and 4 phases, and 60% of -1 events occurs between 5 and 7. If we go to this plot, so what I'm saying is 60% of +1 events occurs when the phase 2, 3, and 4. So when there is a positive anomaly of LFISO occurs over central India, there is a very high chance there will be a +1 events. Similarly, 5, 6, 7, if we can see there is a negative anomaly over the central India, so the -1 event is likely to happen. And 60% of time it happened. HFISO does not show such distinct features as LFISO, but the probability of occurrence of +1 get low when there is a negative anomaly of HFISO exists along with the favorable condition of LFISO. For example, if over central India, it is a +2 event or phase 2 event occurring of LFISO over central India. But along with this phase 2 event or the positive anomaly event, if the negative anomaly of HFISO occurs simultaneously, the probability of occurrence of +1 event decreases. And vice versa also. When the negative anomaly of LFISO occurs and the positive anomaly of HFISO occurs, again the probability of -1 event decreases, and that decreases even strongly. So in summary, although the LFISO primarily modulates the rainfall events over CI, HFISO plays a significant role in modulating the probability of occurrence of +1 and -1 events.
4.64, is it a negative sign?
Yeah, it's -1, . Now we have to discuss the two approaches of studying the intra-seasonal variation, active break spell and ISO modes. Now we'll see the predictability of this intra-seasonal at this intra-seasonal time scale. So before that, why extended rain prediction we need? First, as we have discussed earlier, prolonged and frequent breaks leads to a drought years. For example, 1972, 2000, etc. And long breaks during the critical growth of agricultural crops leads to a substantial reduced yield. Even in normal years also, uneven spatial and temporal variation distribution of rainfall has an adverse effect on agriculture. So accurate prediction of intra-seasonal variation as well as intensity and phase of duration of breaks phase hold a significant importance to the government and the policymakers so that they can take measures to mitigate this adverse effect. Now, why skill is poor on intra-seasonal scale? So since now we have seen that the scale at seasonal and synoptic scale are good, but at intra-seasonal scale, the skill is modest. There are many reasons. I have stated 2-3 reasons. So first, the time scale itself. So extended range prediction means the prediction 10 days or 15 days ahead. And time period is too long to retain the initial condition memory and too short to exhibit considerable influence from the changing ocean boundary layer. And second, extended range prediction of rainfall poses another challenge because of its high temporal and spatial variability at intra-seasonal scale. And in this paper, we will also see that how models like CFS V2 fails to capture the intensity and phase of these ISO modes. Now, coming back to the paper, is so the data they have used is the IMD data from 1901 to 2009, and they have used the forecast data from CFS V2 model, and to extract the MISO or the monsoon intra-seasonal oscillation, which has a time period of 30 to 60 days, they use the method multi-singular MSSA, multi-channel single spectral analysis, followed by significant test. So basically, what they will do, they construct a phase space reconstruction model. They constructed this model based on the MISO extracted on the from the IMD data from 1901 to 1980. And based on this model, they try to find they're trying to predict the MISO of 1982 to 2009 based on the nearest neighbor method. So they just, the procedure of the prediction from, so they did the initial, take the initial stage for each initial state in the period of 1982 to 2009. They search for the nearest neighbor from the state 1901 to 1980. And they took the mean trajectory as a final prediction. So this is the comparison between the PSRM and CFS V2 for the May 1991. And there will be 7 different initial states which span over all the May month. So first initial state they have given at 1st May, then the 6th of May, then 11th, like this 5 days interval. So they previous slide. I'll explain this slide only. So they created one model which was named as PSRM, Phase Space Reconstructed Model. And in this, they have just extracted the MISO, or the MISO is intra-seasonal oscillation modes, from the raw data of IMD. So IMD, they extracted MISO from the raw data. And again, they have done the PCI analysis on this MISO data in order to get this first PC. So this is the red one, is the first PC from the IMD data. These blue ones is the prediction from the PSRM model. And this blue one is the MISO, which get from the forecast data of CFS V2. So they just want to compare how CFS model fails to capture these ISO modes. And clearly we can see that this PSRM model gives a reasonable results, but this model, CFS model, does not able to capture even the magnitude and the phase also. And
observation is so regular.
So this is first PC, sir.
Yeah, so the observation is so regular, it is not surprising that you pick up the mode or the frequency to use the correct forecast.
One second. Observation is the
PSR. I'm not talking about the PSR.
Yes, sir.
It's like what I'm saying that in so it's so regular in period, time period, right? So once you pick up the mode, this because this is maybe happening every year. once you pick it up from your data, it is not surprising that it will give you correctness. Every year maybe it will do the same thing. So there is no surprise there.
Yes, sir. Yeah. So basically, yeah. So for 1991, they had just find the nearest neighbors from the 1901 to 1980 data. Yeah, every year the dominated mode is almost the same. It's between the 40 the average time period is around 40 days. So yeah, it could be, but as the lake time increases, it starts fluctuating also. Beyond the 50 days, it doesn't so much along the coast. But the model fails completely. If you see the plot also, so this is the prediction made on 5th of July, and the initial condition also given at 5th of July. And the first column is the, so they want to predict 5 days ahead, 10 days ahead, 15 and 20 days ahead. And this is the observation from the IMD data. This is the PSRM made prediction, and this is the prediction which forecast made and we extracted the MISO and plotted here. And if you see 10 days ahead, there is a positive anomaly over the monsoon core region, but for CFS V2, it's negative anomaly. So not even the intensity, but it also goes out of phase also. So in order to enhance the prediction skill of models in intra-seasonal scale, they has to capture the intra-oscillation mode that we have discussed, that it's do modulate the rainfall over central summer monsoon also. Now, recognizing the importance and need and the difficulties which dynamical model face, the World Meteorological Organization, associated with ECMW and the Switzerland Meteorological Department, they launched an AI competition, and in that they have to predict 2-meter temperature and precipitation over land at a spatial of 1.5 resolution, a degree resolution for the period of time lag of 3 to 4 weeks or 15 to 20 days, and another was 30 to 42 days. So in that, participant has to use the sub-seasonal to seasonal database. So this database has been created by Vita data in around 2016 and 17, and this they have just collected the reforecast data from 12 major meteorological department, and they put in the same way, just made it similar to each other. So the participant have to develop, train and validate AI models by using 2000 to 19 data, and they have to test for the 2020 data and need to compare the bias corrected ECMW from the forecast made by ECMWF. First team. So it just consisted of the weighted multimodal assemble method. So what they have used is they've taken 5 data. First from ECMWF, second from Canada, third from NSAF forecast data. The fourth data is itself a prediction based on convolutional network, neural network applied to the ECMWF. Fourth data is this, and fifth one is climatology. And again, they run a CNN model to give the weightage to each of these 5 data and find the final prediction. So the important part is, at the line for the, if you see the variable for the percent, this plot shows the percentage given to the climatology, weightage given to the climatology. As the in even the 3/4 week or even the lead time increases, we can see that around 50 to 60% weightage given to the climatology only, and as the lead time increases, it goes up to the 80%. So even though the models are very sophisticated, simple climatology is on par with these models as the lead time increases. The second model use the point-by-point statistical correction method. This they use only the ECMWF forecast data, and at every grid point they used either climatological forecast, logistic regression, random forest classification. They run all 3 models at a particular grid point, and they find out that which model is giving the better result. They took that model. And again, logistic regression performed based on the most of the grid, but still the climatology remains unbeaten in some grids for the week 5 and 6 forecast. And the last, it divided the whole region into 23 similar climate regions, which was provided by the Naval Research Laboratory, Montreal, California. And again, they used the random forest classification model only. And they found that the separate temperature forecasting model they have used for each region, and for precipitation, they have used the single model only. In all three models, they have able to get better results than ECMWF, but still climatology is giving on par, performs on par with any AI model. So as we have discussed, two approaches of intra-seasonal variation. First is active break spell, second is ISO modes, and which is consists of LFISO modes, which moves northward from the Indian Ocean, and HFISO, which moves north-westward direction from the Bay of Bengal. And these modes have great impact on ISMR and modulates the active break spells over the CIM. Dynamical models like as CFS V2 model fails to capture this mode, which may be the main reason of poor prediction skill at intra-seasonal scale. And third, simple climatology still performs on par with any AI model when the lead times increases over 15 days. So, thank you. These are the references. And
thank you for the question. Very nice talk.
Yeah, this is very good. But I have a question that, see, the intra-seasonal oscillation exists because of instability in the atmosphere, right? I mean, the atmosphere and motion. And instability itself is a function of the mean state, right? Then why to study intra-seasonal oscillation to understand the seasonal mean? We should understand the mean of the last mean.
so, intra-seasonal variation.
What I'm asking, it is not surprising that the longer breaks will give droughts. It had to happen because of the large scale forcing. The longer breaks had to happen.
That has to happen, but only know when it happens. So if we
More 23
long break,
Go down, more
10 days
23.
ahead of 15 days ahead, then we can get some measures. We can able to take some measures in order to mitigate that.
For inter-seasonal prediction, it's necessary, but not for the seasonal mean.
Seasonal mean. Yeah, it's obvious that when longer happens, yeah. So yeah, seasonal mean it could be not very important. Yeah, there has been some references that you mentioned that intra-seasonal oscillation does not much effect on seasonal mean. But again, it will modulate the active break spell, which may lead to dot years or even years if the break even becomes 15 to 16 or 20 days.
So the W price is awarded or not awarded? The competition.
Price money was there.
Who won the award?
All three.
How they got the award?
Yeah, so there is first three.
No, there were many others. These are the three best. That
Oh, yeah, the best. Okay. Nobody got 1, 2, 3.
and this is normally the one you point.
I hope they repeat this because to me, in all these papers on AI, and everybody claims he's doing better because you don't compare common. So this is a common one. A very good idea. I hope they repeat.
Yeah, it's a continuing process.
Huh?
There was one first take, but it's a continuing challenge. So
Okay.
people can add it.
Now, I hope some of you participate in it and see what you can do because to me, having a common database and a common goal is the right way to improve. I'm saying this because 60 years ago, when turbulence modeling was at its very primitive stage, Stanford conducted Olympics. Olympics means everybody comes there, makes a forecast with the same data set, same logic. And that really improved the turbulence model dramatically. So this is the only way to improve. Otherwise, there are hundreds of papers, everybody claiming he's doing well and no progress, right? So this is a very good thing. I hope people participate in that. Okay.